Okay, so for this one, I've brought this into here so that we can draw on it a little bit more easily. You will have noticed through reading through the question that we have another multiple choice question. However, it doesn't tell us how many of the statements will be correct. So we're going to have to be really careful with this one. So first of all, what I recommend you do with this one is you take a colour and you identify the vectors that we're talking about. So A is the vector from A to B. So that's then along this bottom line here. Just mark that for yourself. Then let's take a different colour that we have then. B is A to D. So B is this one here. And C, let's have in green, is A to E. So C then is up here. Okay, so which of the following representations are possible when S and T are real numbers, so when S and T are scalars? The first one, T to C is some scalar times by C. So the vector C goes here. Our question is, does the vector T to C, this one here, is that one parallel to this vector? Yes, they're parallel. They go in different directions, so our scalar T in this case is going to have to be less than 0, but it will work. That we can make the vector a little bit shorter, but it's going to be fine because they're parallel. That one's fine. What about A to R? Well, A to R goes from there to there. Is it possible that that is just some scalar times A? Oh, that one is an A down there, I promise. That is an A. Is that some scalar times A? Well, they're not parallel, so that's not possible. You'd have to take A and then a little bit of B as well to get from A to R. So that one, nope, we've checked that. What about then E to G that we're interested in? Where does E to G go? E to G goes across here. So to get from E to G, we could go via F or via H, using the parallelogram rule that we covered in the geometric representation of addition of vectors. So we could take B plus A or A plus B, which is the same. So, yes, this works for when S and T are 1. So that's fine. B to T. B to T goes from here up to here. So we're going to have to take sum of the whole of B plus sum of C. What does this say? Well, that says sum of A and sum of B. But if we go from B and we only use the vectors A and B, we can only stay in this plane at the bottom here. We can't go up like C asks us to. So nope, that one doesn't work. What about T to R? T to R goes from there down to here. And we're going to need sum of C in the negative direction and sum of B in its negative direction as well. Sum of B, sum of C, S and T will be negative, so that one works. It's all about envisaging vectors as instructions that get you to places, and they can't move out of that line, so you're restricted to travelling on that line that the vector is on. Then if I go back to the question, we can test up, see if our answer is correct, and you can see, yes, we've got that one right. Our final exercise here uses a context we haven't really looked at in vectors, but it's a really important context in terms of physics, and that context is forces. So here we have a point P and two forces, F1 and F2, working on that point P, and between these two there is a resulting force F. So we've got P, F1 and F2 in the diagram, and they want you to find the resulting force F as the sum of the forces F1 and F2. Now this word sum is going to give you some idea about what they want you to do here. So let's overlay the screen. Get rid of our previous working out. So the resulting force F is just going to be F1 plus F2. Because if F1 and F2 work together on P, then the result on P will be the same as adding those two forces. So if I go then from F1 and then I add F2 onto this, F2's instructions are to go along 1, 2, 3, 4, 5, 6 and down 1. So 1, 2, 3, 4, 5, 6 and down 1. F2 would come, you can do this with a ruler, down there from the end of F1. And you could do this the other way. You could start off at the end of F2 and add F1, which goes 2 along and 3 up, 2 along and 3 up, F1. Either way, this is the end point of the force, and so I can do this probably better with an arrow. This arrow that I've got here is the force F. Oh, it should go all the way from P and end with an arrowhead here at that point there. And you can see that that's exactly what they've done, although they have a slightly more accurate description. And you can see that you can be a little bit inaccurate up to 1 millimeter, and you would still get the correct answer here. So hopefully this has helped, and hopefully you've had a nice introduction to Matura style exercises. One thing that I didn't mention in the first video, when I was talking about the format and different things, was what you need to do to pass the exam. So in the first exam, you need to get 16 out of 24. So here a pass is 16 out of 24 points. If you don't get those 16 out of 24 points, then there are some special exercises in the second exam that can then count towards these 16 points that you need. So even if you only got 13 or 14 points, if you did fine on the type 2 ones, then you could still make up that mark in the first one. If you do get 16 out of 24 points, then the 2 exams are just marked separately. And I found an example here of one of the, I think it was the, not the main time for last year, it was the exam from this September. And you can see here, the maximum number of points a student could get across both papers was 48 points. So they needed that 16 to pass from the type 1 ones and maybe some from the type 2 ones. Then once they started getting above 24 points, they started getting a 3, a 2, and you see that the range for a 1 is actually quite a big range. So it doesn't make it completely impossible to get a 1 at all. You can get quite a few things incorrect and still get a 1 in the Maths Matura. And I think that this way of being able to compensate some of the type 1 exercises with some of the A exercises, as they're known, in the type 2 paper, means that it's not too difficult to get those 16 points. Of course, you need to learn and you need to make sure you're prepared, but I think it's a relatively fair examination in that sense. If you have any questions about any of the exercises that we've been through here, or about how the Matura is structured at all, then write them down and we can deal with them next week in class.